Hello, my lovelies, it's Susanna, and today I want to show you 5 examples of how to find the roots of exponential functions. Let's start with our easiest example here. Find the real roots of the function that looks like this. In general, if you want to find roots, you just have to take your function and always set it to 0. And now we only have to solve this equation for x. Because we're working with exponential functions, our x is part of the exponent. So to get x out of this exponent, at some point we have to use the logarithm. But I wouldn't use it now because we have this -2 here as well on this side. So let's add 2 on both sides so that we get rid of this part here. Then we have 0 plus 2 equals 2 on this side, and here we have our e to the power of 4x, and this cancels out. Now we only have this exponential part on one side, a number on the other side. Now is a good time to use the logarithm on both sides. I would use the logarithm to this base here, so log base e, which is also the natural logarithm called ln, so I prefer to write this here. So we take ln on the left side and we take ln on the right side. On the left side then we only have ln of 2. You can just calculate this. On the right side, the ln and the e, they cancel each other out, and only what we had in our exponent is what's going to be left. So only the 4x. And now it's way easier to solve for x. We only have to get rid of the 4 here. So let's divide both sides of the equation by 4. Then we have this beautiful ln of 2 part over 4 here. And here this cancels out, and we found our x. This is the exact value. If you want to have the decimal number, you can just type it in your calculator and you get 0.17 as an approximation for the root of our function. Okay, what is different in our second example here? We still want to find the real roots, so we take our function and set it equal to 0. Now we want to solve this equation for x again, and we know we need the logarithm at some point, but we have this 2 times here, so maybe first get rid of the 2 by dividing both sides of the equation by 2. Then we have 0 over 2, which equals 0. And here this cancels out, and only e to the power of 3x is what is left. We still have our x in the exponent, so now is a good time to use ln on both sides of the equation. The problem just is, what is ln of 0? Type it in your calculator and you will get an error, hopefully, because ln of 0 is not defined. So this function here has no roots. We cannot solve for x because we get this error here. So every time you get to a point where it says e to the power of something is equal to 0, you know that you're done. So there is no solution to this equation here. You cannot find any roots here, which is not a bad thing. This function just doesn't have any roots. Okay, next example, find the real roots of this function. So we take it and set it equal to 0. What is different this time? We have a product here, but this time we have x in the first part of the product and another x here in the second part of the product. Every time you have this structure, so something with x times something with x is equal to 0, So this 0 is really important. If you have another number here, this doesn't work, what I'm going to show you now. But if you have equal to 0, then you can split this product here into two parts. You take the first part, the 2x, and set them equal to 0. And then you do the same thing with the second part. So you just take the second smaller part and set it equal to 0. We are allowed to look at these parts individually and solve these smaller equations now individually for x. To solve this for x, we just divide both sides by 2. Then we have our x already, which is 0. So we found a root of our function. What about this equation here? E to the power of something is equal to 0. Nah, we know now that this is not possible. E to the power of something cannot be 0, so we don't get any more roots out of this equation here. This is the only solution we have for our roots. Next example, it gets a little bit more complicated, but we still want to find the real roots. So we take our function, no matter how it looks, and set it equal to 0. What do we have here now? This structure here often happens if you're working with derivatives. So we have a difference here. So we have a first part and a second part. And e to the power of x plus 1 is part of the first part, and it's also in the second part. So things repeat themselves, and we can factor them out. So let's do this. We want to factor out this green exponential part. What is left in my parentheses then? We have the minus here in between. If we factor out this part, only x squared is left. If we factor out this part, only the 4 is left. What do we have here now? A product of something where we have an x inside times something where we have an x inside is equal to 0. We now know how to solve this. We are allowed to split this into two separate equations. We take our first part, e to the power of x plus 1, and set it equal to 0. And we do the same thing with the second part and also set it equal to 0. And now we solve these equations separately. E to the power of something is equal to 0. Nope. Doesn't work. We don't get any solutions here. And here, this is a quadratic equation. We can add 4 on both sides of the equation first, so that we have x squared by itself on the left side. Here we have 4. To solve for x, we have to get rid of the square here. So let's take the square root on both sides of the equation. If we do this, we get two solutions, a first positive solution and a second negative solution. The square root of 4 is 2, and then we have minus the square root of 4, which is minus 2. So we have two roots here. We don't get any more roots, not out of this equation here. Okay, last example. This looks horrible, but we still want to find the real roots. We breathe and we take our function and set it equal to 0. How can we solve this equation now for x? We have x down in here and in here, so we have to get rid of this denominator to be able to solve for x. So let's multiply both sides of the equation then by this denominator. So we write it in parentheses and multiply the right side by this denominator and also the left side by this denominator. on the left side, we have times 0 is just going to be 0. On the right side, this cancels out, and only what we had in the numerator is what is left. Wasn't so complicated, right? Because this is way easier now. If we want to solve for x, we just subtract 4 on both sides of the equation first, so that we have -4 here. And on the other side, we only have e to the power of x, because this cancels out. And what is this now? We haven't had this case here yet, but this is another case of there are no roots of our function. Why? Because if you want to solve for x and you use the ln now on both sides of the equation, then you have the logarithm of a negative number which is not defined. So you can try it with your calculator, but you will get another error. So the things inside your logarithm always have to be positive. The 0 is not allowed, negative numbers are not allowed. So every time this happens, you know, we cannot solve this equation for x, or there are no solutions. So in our case, there are no roots. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.